In this problem, problem 2.4, we're going to look at something called a tessellation. And a tessellation is a design made from copies of a basic design element that cover a surface without gaps or overlaps. So if you see in this image here from problem 2.4, question A, this design, these designs are over and over and over again without any gaps or overlaps. So the design itself is reprinted again and again. And so what we want to look for in a tessellation is what types of symmetry are there. And remember, there's three types of symmetry. There's translation symmetry, there's reflection symmetry, and rotation symmetry. And so some tessellations use one of the three. Some tessellations use combinations of the three, and there are even some tessellations that can use all three. So we want to ask ourselves, when we first look at this design problem, what's the basic design element? What piece or what part was copied over and over again, and how was it moved? How was it translated or rotated or reflected in order to do that? So, and I think you can see from this when the basic design element are each of these squares. And so if I just take one square, one section of this, some might think that the basic design element is this individual element in here, but because they're shading in it, because there's different colors, the darker, lighter colors, then the whole thing is the basic design element. While this interior shape is a design element within the basic design element, you need all four of these together to make the basic stamp or the basic piece that you would have to stamp over and over and over again. And the question becomes, how was it translated, or how was it rotated, or how was it reflected? And if you think about this image, it doesn't really have any reflection points. Like if I take the mirror there and put it next to that original design element, I don't get what's next to it. So it doesn't look like it was reflected into place. Didn't take it and reflect an image. And even from bottom to top, from that one to the one below it, that's not a reflected image of it. So it's not a reflection. And the second thought is, could I have rotated it into that spot? Could I have spun it around? And does it have rotation symmetry? And if you think about the shading in this, because it's shaded, because there's a darker and a lighter piece within it, in order to rotate this, I would have to rotate it all the way around 360 degrees to get it back to this, what it looks like. So it doesn't have rotation symmetry either. It has neither rotation symmetry nor reflection symmetry. So the only possibility is this image was just simply translated or slid to the right, or slid down, or slid at an angle. And so in this case, we'll just look at it as if we slid it across the page or we slid it down the page. And all we really want to know is how far it was moved in any particular direction. So if I think of each of these corners as a point, like if I said this was A, B, C, and D, how far or in which direction did I move each of these to create the new image? And really it's pretty simple, because I just took C. I get to think of it as taking C and putting it over here as C prime, and B over here where C is, so B takes the place of C, and this becomes B prime, and then D prime is over here, and this becomes A prime right here. And the question is, how far was that moved? And it looks like the distance is 2 centimeters. And the direction is, so I could literally take this and say I went 2 centimeters to the right. I could just put that as a sort of like a key here. Say we're going to go 2 centimeters in that direction. So there's my arrow that's 2 centimeters long. Or I could think of it as I translated it down as well. So there's two directions that I'm moving it. So from here to here again is another 2 centimeters in that direction. So it's translated down 2 centimeters. So A, this could be an A prime down here as well. Another location to translate it. And same thing with the D, becomes a D prime here. And this becomes a C prime. So all these points then shift. So you can shift it one direction, or you can shift it another direction, or we even could have thought of if I had gone diagonally and shifted from here to here. So there's really 3 ways that it could be thought of as being translated from one point to another. So in this case, if I were thinking from D to this point here, so in that direction, looks like 2.8 centimeters in this direction. So I could think of my translation as potentially being in 3 different directions, 3 different parts of the plane. 2 centimeters one way, 2 centimeters the other way, or I could think of the angle in between, 2.8 centimeters in this direction. So my possibilities for translations of this image, so 2 centimeters this way, 2 centimeters this way, 2.8 centimeters this way, depending upon which way you decide you would translate that image. So those are my direction arrows and how that basic element can be translated to produce other parts of the pattern. And so if we think about it, does the entire tessellation, the whole thing, have reflection symmetry? In other words, could I find some point in this tessellation where it reflects on itself? And it just doesn't look like there's anywhere where you can put a mirror and see the original image reflected on itself. And that's because of the shading. If this didn't have shading the way it does, a lot of those images would just reappear in places where they would. So it doesn't look like it has any reflection symmetry whatsoever. So this is what's called a translation tessellation. So if we have a translation tessellation, that means that the only movements are directional, not rotational, and there's no reflections, no reflected images in this problem. And we'll next lesson move on to question B from problem 2.4.